western horizontal. So a whole bunch of words right there. We need a picture. So the key word here they give us is western horizontal. So let's just draw really quickly. We've got north, south, east, west. If you don't know your directions, you need to learn them because the next section that we're doing here is very, very heavy on them. So we are 20 degrees below the western horizontal. So 20 degrees below, and we are descending. So those are the two key words there. Descending below the western horizontal. So we know that 20 degrees goes right there. So our plane is headed in that direction. So we want to find the components. Well, that's what I was showing you right here, finding the components. The x component is equal to the magnitude times the cosine of our angle. The y component is equal to the magnitude times the sine of the angle. The magnitude is the velocity, is the force, anything like that. So 150 miles per hour is our magnitude. So our x is equal to our magnitude times the cosine. Now be careful with this. It's not just 20. Your angle must be measured with the positive x-axis, just like it always is. So 20 is a reference angle right there. What is the angle with the positive x-axis? 200. Okay, that is 200. So crunch the numbers, 150 cosine 200, making sure you're in degree mode. We're always in degree mode right now. We get negative 140.954. Now, does that agree with our picture? Should our x-coordinate be negative? Yes, our x-coordinate should be negative. Look at where we're at. We're in the third quadrant, so our x is definitely negative. Notice that if we did not do 200, if we only did 20, we get the same number, but it's positive. Okay, we get the same number, but it's positive because it's still the same magnitude. It's just in the wrong place if you use 20 degrees instead of 200 degrees. The y component, find it the same way, except we use sine, and we are using 200. So 150 sine 200. We get negative 51.303. Does that make sense? Yes, our y coordinate is negative as well, according to our diagram and what has been described. So, component form, put it in the pointy brackets. And you're done. Okay, let's look at another one. Find the component form of the vector that represents the velocity of an airplane ascending at a speed of 100 miles per hour at an angle 45 degrees above the western horizontal. So, similar reference point, we're talking about the western horizontal, but this time the plane is ascending and it's above. So 45 degrees is right here. So the angle that we're truly talking about is 135 degrees. 180 minus 45. Bless you. So our x component is equal to the magnitude, the velocity of the plane, times the cosine of the angle, 135, not 45. 100 cosine 135. Approximately negative 70.711. Again, that makes sense. Check it with your picture. If you will take the time, the 2 seconds that it takes to ask yourself, does that number make sense? You will save yourself wrong answers. Okay, the y component's 100 sine of 135, and that should be positive because we're in the second quadrant, so we have positive x coordinates. Notice they're the same number. One's negative, one's positive, but think about the angle. 45 degrees, you're exactly in the middle of the quadrant. You're at that halfway point, so your x and y components, it makes sense that they are the same value. Just one's negative because of our orientation. All right, any questions there? All right, let's look at example 8. This is a completely separate scenario here. We have these problems that talk about either pushing something up a ramp or an inclined angle, or pulling something up the inclined angle. So here's the scenario. I could go through a big long explanation to tell you why it is the way it is, but it would really take probably 10 minutes to explain everything about it, so I'm just going to give you the scenario. The sine of the inclined angle is equal to force over weight. Force over weight. The way that I remember that, alphabetical order again. F comes before W. Force over weight. Okay? So let's look at the example. A force of 600 pounds, so that's force, that's what's going to be on top, is required to pull a boat and trailer up a ramp inclined at 15 degrees from the horizontal. Find the combined weight of the boat and trailer. So if we set up our scenario, the sine of the inclined angle, so sine of 15 degrees, is equal to our force, 600, over our weight. We don't know it. That's what we've been instructed to find. We're solving for W. It's in the denominator. We need to start by multiplying both sides by W to get it out of the denominator. And then we got to get W by itself, so we turn around and divide both sides by the sine of 15 degrees. So let me just more neatly write what we're looking at. W is equal to 600 divided by the sine of 15. 600 divided by the sine of 15. The weight, the combined weight here is approximately 2,318.222 pounds. Yes. Because that's just, it's always sine in this scenario. It's always sine. It's a good question. It has to do with the whole, they're like similar triangles and stuff like that. So it has to do with the way the triangle's oriented, but I'm not going to go through that part. Okay, let's look at another one. You can be asked to find any of these three pieces of information. So we just found the weight. Let's look at B. A boat and a trailer combined weigh 2,405 pounds. So this time we know the weight. Find the angle of the incline if a force of 500 pounds is required to pull it up. So sine of, we don't know the angle. You can use theta, you can use x, it doesn't matter, just put a variable there. The force goes on top, the weight goes on bottom. What do we do when we need to find the angle? Inverse trig. So the inverse sine gives us an angle of, we'll just round that up to 12 degrees.